Hi everyone, welcome to 816. On our today's lesson, I'm going to explain how we are going to find the derivative of some functions. I think in this lesson, basically, I'm going to explain how we are going to determine or how we are going to just apply an implicit differentiation. That means an implicit differentiation is generally used if the function is given as a combination of two variables. Two variables. In this case, there is two variables which is given in combination, but the derivative is already given, or you are asked to find with respect to one single variable x. You are asked to find the derivative of this function with respect to x. So, if you are a new member of my YouTube channel, don't forget to share, like, and subscribe. 816. Well, now let me explain how we are going to find the derivative of this function with respect to x. Let me come to how we are going to do the first problem. So, when we come to the first problem, that is ln of xy, which is or equal to 4 minus y squared. In order to find the derivative of this problem with respect to x, let's say dy by x the whole, which is given by, now this is perfectly given by dy by dx of x is 1, ln of xy, which is equal to 4 minus y squared. Let me take, or let me find the derivative of this function with respect to x. So, when we find the derivative of this one, first of all, don't forget the principle that means you can look how we are going to determine generally the derivative of ln of any function u of x, with respect to x. That's how we are going to find the derivative of this one. As I have already just explained in my previous video, dy by dx is generally given by the derivative of g. We need to find the derivative of this, and we have to divide for u of x for itself. So immediately you can find, or you can apply the technique of finding the derivative of this one. So with the help of this principle, maybe in the case of this problem, we have a single variable. The function is given as a function of one variable, but in the case of this one, there is two variables here, x and y. So how we are going to determine the derivative of this one? That's why we need to apply an implicit differentiation to find the derivative for this problem. So, to find the derivative for this problem, look how I'm going to split the functions, or how we are going to split the variable that is involved in this problem. So, to find the derivative for this problem, at the very beginning, let's consider y as a constant. If we consider this the second variable as a constant, we need to find immediately the derivative of x alone. So the derivative of x, that means when you consider this as a constant, means that it will be a to x. So how could you find the derivative of this one with respect to x? Immediately, that is 2. So the derivative of this problem with respect to x will be, or given at this as immediately y, because the derivative of xy with respect to x will be, you have to consider this as a constant. We need to simply find the derivative of x. So the derivative of x is always 1. So y plus, now plus, let's consider again for the first variable x as a constant, and let's find the derivative of y. So that will be, this is a number or a constant. So the derivative of this problem with respect to x will be x times dy by dx. But see, don't forget to put, because whenever we consider this as a constant, the derivative of this, the whole problem will be y over what? xy. That, as I have already mentioned before. Similarly, now this is the derivative, but we need to find the derivative of this problem. The derivative of this problem, considering x as a constant. Now, y as a constant. The derivative for this problem will be x, and this has to be divided by the function itself, this one xy. So it's the constant. So again, this is given by, what's the derivative of this with respect to x, the derivative of any constant is always 0, minus the derivative of y with respect to x is given by minus y times dy by dx. Because do you know the reason why we use dy by dx? Because this is the function y, and we are asked to find the derivative of this with respect to x. Is that with respect to x? And because of that, we need to just find the derivative of this, and we need to write again this one. So let's calculate like terms together. Now this implies that now this can be done as x. Now you know this will, when we simplify this problem, we have 1 over x, because this is cancelled by this one, plus x cancelled by x, plus 1 over y, which is dy by dx, and let's bring this on this side, plus 2y times dy by dx, and this is immediately 0. Is that? So now this is the value. And then when we rearrange this problem, we can have this kind of value. That we can have this kind of value. Let's bring this here. So when we do this one, we have dy by dx common. Is that? And let's move this on the right side. Is that? When we move this on the right side, we have left this one on the left, and dy by dx is common. Therefore, dy by dx into what's left here, 1 over y, plus what's left here, 2y, which is given by negative 1 over x. Is that? When we move this on the right, that will be negative 1 over x. Now we have this one. Then finally, let's simplify, or let's put the final solution for this problem. Is that? So when we just do this one, dy by dx is times, when we simplify this one, it will be 1 plus 2y squared over y, which is equal to negative 1 over x. So let's multiply both sides by the reciprocal of this one. So the reciprocal for this is given by dy by dx is times y over 1 plus 2y squared times 1 plus y squared over y, which is given by negative 1 over x times y over 1 plus 2y squared. Is that? So this is cancelled by this one, and this is cancelled by this one. And finally we have dy by dx is immediately given by negative y over what? Negative y over x times this x plus x times y, 2x y squared will be the derivative of this function with respect to x. Is that? So this is the way how we are going to find the derivative of the first function ln of xy, which is 4 minus y squared. Is that? It's an implicit differentiation. You can find the derivative for any problem. But let you know the principle of the rules. That's very important to find the derivative of any function in general. So let me come to the second problem. How are we going to find the derivative of the second problem? Now, in order to find the derivative of the second problem, see, we need to apply the same technique. Is that? So we have these two functions x and y. First, let's find the derivative of this function with respect to x, considering n and y as a constant. So when you consider that one as a constant, we can have the derivative of take dy by dx both sides, that, and that will be x ln of y, which is 2x plus 5. I'm taking just, let's consider this as a constant, and the derivative of this will be what? ln of y. Is that? ln of y. We have left only this one, because the derivative of this is only 1 times this constant will be this one, plus, because there is a product of two variables, that, plus, considering this x as a constant, let's find the derivative of this one. As you know, the derivative of this ln of y will be what? Derivative of this, derivative of y is always 1 over, and the function itself y times x times dy by dx, which is given by, and what is finally the derivative of this one? The derivative of this with respect to x will be only 2. Is that? Because to x the derivative is 2 and 5 is constant, so the derivative of this function with respect to x will be 2. Is that? So now we have this one. And finally, what we're going to have from here, ln y plus x over y, which is divided by dx is given by 2. Is that? Then now the point here is solving this one in terms of some other variable. Is that? Let's move this on the right, and which is given by x over y times divided by dx is immediately given by 2 minus ln of y. That, and again let's multiply both sides by y over x. Now let's multiply this by y over x. Is that? And finally this is cancelled by this one, and this is eliminated by this one, and we have this solution. Is that? So the solution for this problem will be this one. Let's bring this here. Divided by dx is immediately given by y times this will be 2y minus y ln of y over what? Over x. Is that? So this is the final derivative for the differential. Is that? So this is all about our today's lesson. Maybe if you have any questions, doubts regarding to this one, you are welcome. If not, don't forget to share, like, and subscribe 816. I think this lesson is very important for A-level Cambridge student, and also it is very important for Ethiopia national students. For grade 12 Ethiopia national students, just will look and you can just get some concept how to find implicit differentiation, or how we are going to find the derivative of any function which is given as a product of two variables. This is all about today's lesson. Thank you for watching.